Hello, my name's Daniel Nolan and I'm the co-founder of the Scimeta project. I just wanted to explain what the Scimeta project's about and how will this benefit people. Well, my idol is Nikola Tesla, and I'm sure lots of you have heard who Nikola Tesla is. And when I first seen Tesla's work, I was about 20. My comment, and I always remember it now, is if it was this efficient, I would have heard about it at school. And isn't that very ironic that that's where we're at the moment? We're at a part where we have all this amazing technology, being able to put stuff on the internet, but basically all the stuff which is really great information and what we should be told isn't even taught to us at school. And that's when I started experimenting with this as a hobby, and any spare time that I had, I was experimenting, I was learning, I was researching, I was doing as much as I could, and it made that much of an impact on my life, trying to understand what Nikola Tesla was doing in his work, that I ended up going to university and studying electronic engineering. And what was amazing about that was even the teachers there, when I was showing some of my experiments, they'd say things like, oh, that can't work, the diode's backwards, or where are you getting all these ideas from? And it was a combination of the internet, but it was really in essence Nikola Tesla's work. And obviously he made a big impact on science. Like, we use AC electricity, which powers our modern daily lives today. And that was one of his early patents, that and he had a little tiff with Edison, you could say, which was called the War of the Currents between AC and DC. And really that was just about how to transmit power for long distances without having the most efficient, without wasting as much energy. So basically with AC they could step it up to higher voltages, lower currents, and push it through the lines, and then step it back down again, like we're still doing today. And then we can actually use that to power our devices and appliances. Where Edison's method was using DC power stations every couple of kilometres and having huge copper wires, being able to actually push the energy through them because of the high currents needed to actually push the energy. Well, in a short answer, Tesla ended up winning the War of the Currents, and here we have AC electricity today. But this is the tip of the iceberg. He had so much other brilliant things to do with motors, dynamos, and radiant energy. And that is where my passion lies. Today we would refer to this more as zero-point energy, and that has been my inspiration to do all these experiments with the technology, because we found that when we expand and collapse a magnetic field, that we get all this energy, the zero-point energy, the divergent energy that wants to escape. And this is the energy which can really be the breakthrough for the future. And we can refer to this as new energy technologies, or some people would like to say free energy, but that's not the case because nothing's free. What we're looking at is a zero-point energy. So in a short sort of explanation, zero-point energy is when you take all the heat out of an object, a particle, there should be no energy present. So we're bringing this down to minus 273 degrees Celsius, or 0 degrees Kelvin. However, there was still energy present. And therefore, we had to actually create a new term, a new analogy to explain this. And that was where the coined phrase of zero-point energy comes from. So when we're looking at all this excess energy which is coming out of some devices, or when we're getting vibrations, if you vibrate a circuit, you get a lot more energy out because it's like ringing a bell, you're getting this excess energy coming from the echoes. And that's all the magnetic fields are. So when in my experiments, I was doing low voltage, so 12 points input energy, and I was collecting energy on the other side, taking it from 25 to 40 volts. And when I discharged this energy, we could see huge amounts of light present just before the current starts to flow, which current is basically electron flow as they teach us at school. This is completely inverse or opposite to what I've been taught. I'd always been taught that you get the sparks, the current flow, and then you get a little tiny flash of light. Well, if I'm only using 40 volts on the output side and discharging it, why am I getting huge flashes of light? And then I'm getting the current flow, the sparks afterwards. And this is exactly what Tesla was saying. And when he actually started researching radiant energy, it was because the people, when they were doing the big power generators around 40,000 volts, so many amps, there was big lightning strikes coming off these wires before the current could even catch up. And this scared a lot of people, so they wanted to ground the energy. But Tesla, being the scientist that he was, wanted to know where is this energy coming from. And that changed all his experiments, where he moved away from AC and started moving into pulsed DC. And basically what he found is the moment you close the switch, so we can look at it like a light switch, turning it on and off, but really we're just shorting the circuit, the magnetic field. That is where all this energy is coming from, because it's the collapsing magnetic field which yields all this excess energy. So the radiant energy search or 0-point energy search got me to look into circuits from John Bedini, looking into Moray's work, doing lots of replications of anything that I could. And I found that we could even put diodes on the output side and reverse the polarity, so have an opposite. And think of a diode as a one-way street. So if we know that our energy should be moving in this direction, and we put a diode in the opposite direction, therefore no positive energy can go to that output of the circuit. It can only allow the inverse, or the radiant 0-point energy to come through. And we found that this energy comes through like waves. It comes through in vibrations or fluctuations. So the energy isn't always constant, but what we can actually do is we can actually harness that just by collecting this in diodes or collecting it in a capacitor, and then using this energy at a later date, either shorting it or putting that straight into lights or batteries, run motors, whatever you need to do with it. But that is where all this sort of search or the quest is actually coming from, because I want to really get into the research of continuing Tesla's original research into the impulses and finding out what we can actually do with this energy. And in my experiments, I've found that for one, we can generate so much more light or visible energy which is around, and we can look at light as an electromagnetic wave or a photon. So if we're only using a low amount of energy and getting a huge amount of light source on the other side, this isn't going through a globe, this is actually just projecting the energy right in the air. We find that there's a huge amount of ambient or available energy just in our environment. And therefore lies the key. How do we tap this energy? Because we understand that we can get it from the vibrations, but this is something we're only picking up a fraction of what's available. So what we need to do is we need to go back in essence, look at Tesla's research, and try and understand it in modern terms, and even just replicate his stuff on a small scale and then build up from there. Only through that will we be able to actually understand where this is coming from. And that's really my quest for the Scimeta project. And what I've done for this year is I've organised collaborations for the year 2014. And what I want to start doing is, obviously I have my own original research, and I'm going to get other people to help me do these independent experiments in various countries, so we can actually determine how to get more of this radiant energy. Because it doesn't help anybody if we only understand 10% or 5% of it. If we could understand this even 50% or 80%, the amounts of energy we can get out of the other side could really help in energy efficiency. So instead of us actually looking at it from a power point of view, how much we're paying, we could just drastically reduce that cost by 20 to 50%. That's huge. On top of that, if we're looking at the amount of energy, if you're taking coal, nuclear, diesel, any sort of carbon-based technologies, this has a huge footprint on society. So it's basically the revolution for green technology. And then what we can do is we can use a system where basically we could either be using solar, we could be using wind, we could use water, or we could actually just devise something where the energy comes straight from the vibrations. Because we know that all the energy is coming from the oscillations or the collapsing magnetic fields. And therefore, all we actually need to do is create some sort of system where we have a magnetic field, copper wire, and then we just create a vibration between the two. Tesla used a lot of mechanical oscillators, so basically he was just using a device which would vibrate something mechanically, like an arm or a piston, and moving that back and forward rapidly. And he found that was his way of getting all this energy. And I like to use the analogy, it was like him ringing a bell. And then he was just using this excess energy and siphoning this off the top for his power needs. So I know I've explained quite a lot about Tesla's work on 0-point energy, but I just really wanted people to understand this, because that was the whole point of really coming together and doing the Scimeta project, because it's so hard to do things by myself. So I found a lot of like-minded people that have passion just like I do and really want to do something to help make some change. And with the power of the internet and social networking these days, there's no reason why we can't have this technology, do the research, put the stuff out open source, and get everybody to do things from benchtop models, little basic things that you can run with a 1.5 volt little battery, 9 volt battery, 12 volt battery, or scale it up to an industrial level and really make some change. Because if people are aware of what's happening now with our global footprint, there's a huge amount of energy wastage for one. We have a very antiquated system where a lot of the technology is very old, but they continue to use it because that's the current paradigm. So we need to shift away from this and try and work out how can we harness this energy and how can we use more of this to benefit us for the future. And hopefully this will inspire some people to support what we're doing at the Scimeta project, and then through that we can actually bring out our information open source and have webinars and demonstrations and actually showing a concept of either the theory, which has been gone through and validated with experimental models, because to me that's what science is all about. You can have a theory, but you have to back it up. You need to be able to show practical applications. And that's that word right there, a practical application. If we don't have a practical application, there's no real point having this technology in the first place, because all it's ever going to be is theoretical physics or an equation looking on a page at you. So that's our goal. We want to make practical applications. We want to have multiple people verify these experiments and independently do the research like us. And then we can actually release this information open source. And then what we can actually do is this will inspire new entrepreneurs, innovators, people already in energy generation, people in sustainability, green technology, and then move that up to the industrial level. So what we can do is start even reducing our global footprint by, I say 20–50%. That's a really simple target. There's no reason why we can't do that. And if we can actually increase the efficiency, even if people still want to use old systems of burning coal, then you don't need as much coal. You significantly reduce that. But then, if you have a look at what Tesla was trying to do, he used a lot of his things next to water supplies. Niagara Falls in America is a very popular thing. Everyone's seen the big water coming in there. But when you're looking at the very first large-scale power generation site, it was there. And Tesla was the founder of building the Niagara Falls technology. He did that with General Electric, Westinghouse. And from that actually transmitted, I think it was 20 miles, so around 28 kilometers, 25 kilometers to Buffalo, New York. So that was a massive achievement at that stage. But this is something that he had as a dream since he was a little kid. He was even building that same concept in a river, and he found that you can use the flow of water, because it's not static, it's kinetic, it's constantly moving, to actually generate out all that energy needs. And he did that in the form of actually using the water pressure to spin shafts, and therefore spun the generators up to a certain speed. The generators have coils inside, which obviously have magnets beside the coils. That conducts our electricity, and then therefore all we have to do is transport that from point A to point B. So thanks for listening, and hopefully this inspires people to come and see what we're doing at the Scimeta project. And please check it out, check out our work, our collaborations, our events, and it's been a pleasure spreading the passion.